Hi guys, welcome back to my channel. So on this video we are going to be sketching the even and odd parts of this signal. So as you all know that the formula for the even and odd part of the signal is given by x of t. This is x of t even, this is e, equals to x of t plus x of minus t all over 2, right? So this is the even part. This is the formula for the even part. So the formula for the odd part is given by x of t, this is odd part, equals to x of t minus x of minus t all over 2, right? So we all know that every signal contains even and odd parts. The signal will always contain an even and the odd part. So now for this particular signal, let's sketch out the even and the odd parts of the signal. So the even part, so I think we have the x of t already to be this, to be the original signal. We have the x of t to be the original signal. All we have to do is what? Perform a time reversal on this particular signal to get this particular part. So we're going to perform a time reversal now on this signal. So let's perform a time reversal on the signal. So once you perform a time reversal on the signal will just what? Become something like this, right? So this is x of minus t. So that is just time reversal. So we've already gotten the x of minus t, right? So all we have to do is what? Add the two signals together. Add them together. So adding them together, we have, to get the even part, we have what? At, let's do it the easier way. So at t, this is t, at t equals minus 1, the amplitude here is what? 0. So we at minus 1, it is 0 plus, at minus 1 here, the amplitude is 2. You know why? Because at any point, because this part of the signal is a unit step function, it's a unit step signal, so it means it is 2 at any point. It has an amplitude of 2 at any point on this part. So it has an amplitude of 2 at any point on this part. So we don't really know where minus 1 is, but we know that it will be 2, because it is 2 at any point. At 3 is also 2, at 4 is also 2, at 5 is also 2 till infinity. So all we have to do is at minus 1 here, the amplitude here is what? 2, which is what? 2 plus 0 plus 2 is what? 2. So at 0, what do we have? At 0, we have what? 2, because we have an amplitude here. At 0, we have 2 plus, that's 2 plus, at 0 here, at 0, we also have 2, so which is what? 4, right? So at 1, also, like just like we did for this side, at 1 we know that is also 1, just like I said before. So at any point here, it will always be what? 2. So at 1 it is what? 2. So we have what? 2 plus 2 plus at 1 here, the amplitude here is what? 0, because there is no height. It went to 0 at 1. So we have 0, which is what? 2. We can also do at 2. At 2 here, we also have 2, right? Just like before, at 2, we have 2. We are not given 2, but we want to know what happens after this. Are we going to be getting a constant number, or we are going to be getting a varying number? So to be able to know how the signal continues after this point, so don't get confused about that. So this is at 2. We have the amplitude to be what? 2. We have the 2 plus at 2 here. At 2 here, we have the amplitude to be what? 2. Sorry, to be 0, right? Because we don't have any height. The signal here is 0, so there's no height here. So we have it to be 0, which is also 2. Which means if we do for 3, you will also get 2, right? If we do for 3, you also get 2. If you do for 4, you also get 2. If you do for 5, you also get 2 till infinity. So even at this point, even at minus 2, right? At minus 2, you can also see at minus 2 for this, we have 0, right? 0, because there is no height. Minus 2, there is no height here. 0, we have 0 plus at minus 2 at this point, minus 2, we have it to be 2, right? 2. So we have 2 till minus infinity, and 2 till plus infinity. So which means our signal, which is the even part of the signal, will be what? We want to sketch it now. We're given by this. So we have minus 1, we have 1, we have 2, we have minus 2. We can also do minus 3, minus 4, minus 5, minus 6. We can also do 1, 2, 3, 4. So let's just stop at 2, right? So we have 4 and we have 2, because we have 4 here, right? And we have 2's. So all we have to do is what? At minus 2, right? At minus 2, we have it to be 2, right? So we have 2. At minus 1, we have it to be what? 2, right? Also 2. So all you have to do is draw a line, which means it goes to infinity. The line goes to minus infinity, and at 0, this is 0 here, this is 0 here. So at 0, we have it to be 4, right? We have the amplitude to be 4. So draw the line to that point. At 1, you have it to be 2, right? You have it to be 2. And at 2, you have it to be also 2. So you can just do like this, and then do like this, which means this also goes to the infinity, this also goes to the infinity. So you have it to be this. Remember, we are trying to sketch the even part. We are not done with this, because we still have to divide by 2. So make sure you don't forget that part, because a lot of people forget to divide by 2. So don't forget to divide by 2. So let's just divide by 2. All we have to do is what? Divide the amplitude by 2. It doesn't affect the time. So all you have to do is divide the amplitude by 2. So we have the final even part to be given by 4 divided by 2 is what? 1, and 4 divided by 2 is 2, and 2 divided by 2 is given by 1. So just like this, also goes to infinity, and minus 1, 1, 2, 3, minus 2, minus 3 till infinity. So we have the even parts. We have the even parts of the signal. This is the final even part of the signal. So we have the even part of the signal already to be this, right? So we are going to be finding the odd parts of the signal. So we are just going to be using this formula, right, to find the odd part of the signal. And all we have to do is what, remember we added, when we were finding the even part of the signal, we are adding these two signals together. We are adding the x of t and the x of minus t together, right? But this time around we're going to be subtracting those two signals from each other. So you are going to be subtracting x of t minus x of minus t, right? X of minus t and x of t. So we're going to be subtracting x of minus t from x of t. So all we have to do is what? So at minus 1, for the first one, x of t at minus 1, we have it to be 0 minus at minus 1 for this part, we have it to be what? 2, right? We have it to be 2. So equals minus 2. So at 0, we have it to be what? 2. We have it to be 2, right? Minus 2 here, because at 0 here is also minus 2. There is a vertical distance, so also minus 2, which gives what? Which gives 0, right? So at 1, we have it to be 2, right? A vertical distance, that's the amplitude of 2, right? So we have 2 minus, so at 1 here, it doesn't have any vertical distance, like at 1 is 0. At 1 is 0, so we have it to be 0 equals to what? 2, right? You can also do at 2. You also have it to be what? 2, right? For the first one, you also have it to be 2 minus at 2 here. At 2, you have it to be 0, right? You have it to be 0, so you have 2. So which means if you do for 3, you also get 2. If you do for 4, you also get 2. If you do for 5, you also get 2. So if you do for 5, 2 minus 0 is still the same. You get 2, right? So let's do at minus 2 also. Let's try at minus 2. It's not necessary, it's not really necessary you do this, but just to know what happens after the signal. But make sure you do one, at least one. They give us just up to minus 1. They gave us just up to minus 1, but make sure you do at least one of whatever is outside. Like we are given to minus 1, right? So let's just do, you should just try like minus 2 and do for 2 also, at least 1. So we did 2 minus 2. We also did 3, so you can do till any point. So that is, I hope you understand what I'm trying to say here. So at minus 2, At minus 2, you have it to be 0 also. And at minus 2 for the second one. At minus 2 for the second one, this is x of minus t. Let me write it again, x of minus t. So at minus 2, at minus 2, you have it to be 2, right? At minus 2, you have it to be 2 at any point. So you have what? Minus 2, right? So let's sketch out the signal. So the signal will look something like this. The signal will look something like this. That's 0, minus 1, 1, minus 2, and 2. So at minus 2, you have it to be minus 2. Let's see, this is minus 1 and this is minus 2. This is 1 and this is 2, right? So at minus 2, you have it to be 2, right? So dot the place. At minus 1, you have it to be minus 2, right? At 0, you have it to be 0. So there is no vertical distance, so you have it to be 0 here. At 1, you have it to be 2, right? At 2, you have it to be 2 also, right? You can also do for 3 also, you have it to be 2 also. So all you have to do is join those dots together. Remember, we also have dots at 0 also. So it goes like that till infinity. So it goes till infinity, and this also goes till infinity. Remember, we still have to divide by 2. So don't forget to divide by 2. So what you have to do is what? Divide the amplitude. Divide the amplitude by 2. So the final signal will look something like this. The final signal will look something like this. You have 1, 2, minus 1, minus 2. You have 2 divided by 2 is give you 1. 2 divided by 2 will give you minus 1. This is 0.5. It's not necessary you put this because we don't have any signal at that point, so you can also put 0.5. It's not necessary, so because we only add 2 and 0, right? So what you have to do is what? Just draw the same signal you had before. Remember, it doesn't affect the time, so join this, and then you have the odd parts. So this is the final odd parts, right? So we have the odd parts and we have the even parts. So you can also try adding them together. If you add them together, you're going to get this back. You're going to get this original signal back. If you add them together and you didn't get this original signal back, there's a problem somewhere. But this will definitely give you this signal back. So thank you for watching. Don't forget to subscribe.